For as long as humans have gazed up at the sky, Earth's steady rotation has been our most reliable clock, quietly marking the passage of days and nights. This cosmic rhythm has shaped our lives, our calendars, and even our sense of time itself. But now, something unexpected is happening, something that's making scientists around the world sit up and take notice. For billions of years, the moon's gentle but persistent gravitational pull has acted like a brake, gradually slowing Earth's spin. This tidal interaction has lengthened our days ever so slightly, year after year, and shaped the ebb and flow of our oceans. It's a cosmic dance that's been unfolding since the earliest days of our planet. But in a surprising twist, recent measurements have revealed that Earth is now spinning just a little bit faster than before. This acceleration is subtle, almost imperceptible to us in daily life. But it's real, and it's measurable. Scientists are poring over mountains of data, searching for clues to explain this sudden change in our planet's tempo. This isn't the stuff of science fiction or wild speculation. The world's most precise atomic clocks, capable of measuring time down to the tiniest fraction of a second, have confirmed the shift. These clocks are so accurate that they can detect even the smallest changes in Earth's rotation, and their verdict is clear. The cosmic clock is ticking just a bit faster. The difference may be only a few milliseconds, barely enough for most of us to notice. But in a world that relies on ultra-precise timekeeping for everything from GPS navigation to global communications, even the tiniest shift can have big consequences. Our entire system of measuring time is built on the assumption that Earth's rotation is predictable, but now, that assumption is being challenged. For the average person, life continues as usual. We wake up, go to work, and live our lives without ever feeling the planet's subtle acceleration. The sun still rises and sets, and the world seems unchanged on the surface. But for scientists, this unexpected speed-up is a fascinating puzzle. It's a mystery that connects the forces of climate, geology, and physics, and it's prompting new questions about how our planet works. Could changes in the atmosphere, shifting ocean currents, or even movements deep within Earth's core be responsible? This phenomenon is a powerful reminder that Earth is not a static, unchanging rock. It's a living, breathing world, dynamic, unpredictable, and always evolving. From erupting volcanoes to swirling storms, our planet is constantly in motion, and sometimes those motions can surprise us. To truly understand why Earth's spin is speeding up, scientists are digging deep, both literally and figuratively. They're examining ancient rock layers, drilling into ice cores, and using cutting-edge technology to peer into the planet's hidden depths. Each new discovery brings us closer to unraveling the secrets of our ever-changing world. The story is just beginning, and the clues are scattered everywhere, from the rapidly melting ice at the poles, which can shift the planet's mass and affect its spin, to the swirling molten core beneath our feet, where powerful forces are always at work. As we continue to investigate, one thing is certain: the cosmic clock is ticking, and its pace is changing in ways we're only beginning to understand. Picture an ice skater spinning on the ice, arms pulled tightly to their chest. They whirl faster and faster, almost a blur. This simple move is a perfect demonstration of a powerful law of physics. When you pull mass closer to the center, you spin faster. It's a trick every skater knows, and it's the same principle that governs the motion of planets and stars. The tighter the spin, the greater the speed. But when the skater stretches their arms out wide, their spin slows dramatically. The energy hasn't disappeared, it's just spread out, making the rotation more gentle and controlled. This is called the conservation of angular momentum, and it's not just a trick for athletes, it's a fundamental rule of the universe. Earth, our home, works in exactly the same way. Its spin, what we call a day, depends on how its mass is distributed. If something shifts even slightly, the speed of our planet's rotation can change. Our planet isn't a solid, unchanging ball. Instead, it's a dynamic, ever-shifting system of rock, water, and air. The continents drift, the oceans slosh, and the atmosphere swirls, all constantly in motion. When mass moves closer to or farther from Earth's axis, like when polar ice melts and sends water flowing toward the equator, our planet's spin subtly shifts. It's as if Earth is adjusting its own arms, pulling them in or stretching them out. For billions of years, the moon's gravity has acted as a cosmic brake, pulling on our oceans and creating tides that ever so slowly drag Earth's rotation. This tidal friction has gradually lengthened our days, turning what was once a 6-hour day into the 24-hour cycle we know now. But now, new forces are at play. Melting ice sheets, shifting magma deep beneath the crust, and dramatic changes in weather patterns are all redistributing Earth's mass. These changes might seem tiny, but they're happening on a scale of billions of tons, enough to make a difference. These shifts are minuscule from our perspective, fractions of a second here and there. But on a planetary scale, they add up, nudging the length of our days and the speed of our spin in ways we're only just beginning to measure. The real mystery isn't about some outside force acting on us, it's about Earth's own restless nature, how its internal movements, from earthquakes to ocean currents, are constantly rewriting the story of our days. Even the smallest shifts, billions of tons of water pouring into the sea, or mountains eroding grain by grain, can nudge our planet's spin ever so slightly. It's a reminder that even the most massive objects are never truly still. Right now, the forces speeding up Earth's rotation are winning, if only by a hair. Our planet's pirouette continues, shaped by the dance of ice, water, rock, and sky in a cosmic ballet that never truly ends. The air above us isn't just for breathing, it's a player in Earth's spin. Shifting wind patterns like El Niño and La Niña can speed up or slow down the planet by transferring momentum. As climate change alters global winds, the atmosphere's push on Earth's rotation may be growing. High-altitude jet streams and pressure systems move air mass around, subtly tweaking the planet's spin. The effect is minuscule day to day, but over years, it adds up. The same forces that bring storms or sunshine are part of this global balancing act. Our weather and the length of our day are more connected than you might think. Predicting Earth's exact rotation is a challenge, thanks in part to the ever-shifting atmosphere. The air is an invisible hand, always nudging the cosmic clock. Earthquakes do more than just shake cities and rattle our nerves. They are powerful reminders of the dynamic forces constantly at work beneath our feet. When the ground trembles, it's not just buildings and roads that are affected. The very structure of our planet is being rearranged, sometimes in ways we can barely imagine. These seismic events can actually shift the planet's mass, redistributing it across the globe, and even tweaking the way Earth spins on its axis. It's a phenomenon that connects the deep interior of our world to the passage of time itself. Take the 2004 Sumatra earthquake, for example. This massive event not only triggered a devastating tsunami, but it was so powerful that it caused the entire planet to wobble slightly and shorten the length of a day by a few microseconds. It's astonishing to think that a single event can have such a measurable impact on the rotation of the Earth. The science behind this is similar to a figure skater spinning faster when they pull their arms in. When massive amounts of rock and earth move closer to the planet's axis during an earthquake, Earth's rotation speeds up ever so slightly. It's a subtle effect, but over time, these shifts add up. But earthquakes aren't the only players in this planetary ballet. Deep within the Earth, the swirling molten core and the ever-shifting mantle are constantly in motion. These hidden forces are just as important, quietly influencing the way our planet spins and moves through space. As the core and mantle shift and flow, they transfer momentum throughout the planet. This ongoing movement adds another layer to the story of Earth's rotation, making it a complex and ever-changing process. Most of these changes are incredibly slow and subtle, unfolding over thousands or even millions of years, yet they are always happening, shaping the world we live in and the very rhythm of our days and nights. Earth's geology is like a constant background hum, an ongoing process that sculpts mountains, carves valleys, and even influences the length of our days. The forces at work beneath the surface are always active, even if we can't see them. The same forces that build towering mountain ranges and slowly move continents across the globe are also responsible for spinning the clock of our planet. Every shift, every tremor, every flow of molten rock is part of this grand, interconnected system. Each earthquake, each volcanic eruption, and each subtle movement deep within the Earth is a tiny adjustment in our planet's cosmic dance, a dance that has been ongoing for billions of years and will continue long into the future. So the next time you feel the ground tremble, remember, the Earth beneath us is never truly still. It's alive with motion, shaping our world and keeping time in ways both dramatic and invisible. Melting ice at the poles is one of the biggest new factors in Earth's changing spin. As glaciers in Greenland and Antarctica melt, water moves from the poles toward the equator. This should slow Earth's spin, like a skater extending their arms, but there's a twist. Changes deep in the planet's core are currently overpowering the braking effect of melting ice, causing a net acceleration. It's a tug-of-war between surface melt and core dynamics. Understanding this balance is key to explaining why our days are getting shorter, despite climate change. Human activity is now a measurable force in the planet's rotation. Our impact reaches deeper than we ever imagined. So, what does a faster spin mean for us? The difference is tiny, just milliseconds. On June 29, 2022, Earth set a record. The shortest day ever measured, 1.59 milliseconds under 24 hours. You won't notice it, your coffee, your commute, your sleep, all unchanged. But atomic clocks and astronomical observations can detect these minuscule shifts. This is a triumph of technology. We can measure what we can't feel. The gap between atomic time and Earth time is growing, and that matters for our digital world. For most of history, it didn't matter if the planet wobbled a bit. Now even a millisecond matters to the systems that run our lives. The cosmic clock and our human clocks are drifting apart. To keep our clocks in sync with Earth's spin, we've added leap seconds since 1972. But with Earth speeding up, we might soon need to subtract a second, a negative leap second. This has never been done before. The clock would skip a second, jumping straight to midnight. The International Earth Rotation and Reference Systems Service decides when to make these adjustments. A negative leap second could happen as soon as 2029, but Earth's spin is unpredictable. Why bother? We want noon on our clocks to match the sun's highest point. The leap second system keeps atomic time tethered to the sky, but now that compromise is being tested. The rules of timekeeping are up for debate. We're entering uncharted territory. A single second may seem trivial, but for our digital world it's a big deal. Computer systems, stock markets, GPS, and the internet all rely on precise, continuous time. Leap seconds, especially a negative one, can cause software glitches, crashes, and confusion. No one's ever dealt with subtracting a second in real time. It could create bugs we haven't even imagined. That's why many technologists want to abolish leap seconds altogether. Astronomers want to keep time linked to Earth's spin. Engineers want stability for our machines. The debate is heating up as a negative leap second looms. How we define time will shape the future of technology and our connection to the cosmos. So, should we worry? Not at all. Earth's faster spin is a scientific curiosity, not a crisis. The changes are tiny, with no impact on daily life or the seasons. But it's a golden opportunity for science, pushing us to understand our planet as a complex, interconnected system. The leap second debate highlights the tension between our astronomical heritage and our digital future. Soon we may let atomic time run free, untethered from the sun. The story of Earth's spin is a story of change, and our ability to measure and marvel at it. So next time you check the clock, remember, you're part of a cosmic dance that never stops.